Well, the map of eastern England at this moment has been changed. The familiar curve of East Anglia, the estuaries, the Thames Mouth Islands, firm enough lines in your atlas, now have no boundaries but at the will of the sea.
On the night of the 31st of January 1953, the sea broke through on the east coast of England. By ill luck, a huge storm coincided with an exceptionally high tide. Thousands of hectares of land were flooded. Over 300 people lost their lives.
Now that terrible storm happened about 40 years ago, at which time the East Yorkshire coast stood about here. Of course, the sea isn't quite as rough today, otherwise I wouldn't be standing here either. But in those 40 years, the coast has worn right back to there.
The 50 kilometres of coastline to the north of the Humber estuary, called the Holderness Coast, suffers one of the highest rates of erosion in the world. On average, between 1 and 2 metres of this coast will be washed into the sea every year.
Well, that spectacular rate of erosion is an extreme example, and fortunately, it's not like that right round the whole coast of Britain. But it's a reminder that the coastline, which looks so fixed and stable on maps, is in reality quite fragile and constantly changing in shape.
The shoreline of the British Isles is one of the world's great natural battlegrounds. But even in really high seas, hard rocks like these will erode only very slowly. Other rocks, less tough, will erode faster. In some places, changes can happen almost overnight. And it's waves like this, whipped up by strong winds, that can do most damage.
Now, if you've ever walked along the beach and watched the waves breaking on the shore, you've probably noticed that some waves are bigger than others. Now, it's not true, incidentally, that the seventh wave is always the biggest. But it certainly is true that big waves carry more energy than small waves. And the bigger the wave, the greater the energy.
The sea isn't always this rough. This is a more usual sight. The waves are smaller and they're not reaching the base of the cliff.
When the waves do get up to the base of the cliff, this is the kind of erosion that happens. On a high sea, the waves can force water and air right into these cracks and literally blast them apart. Now, I don't think it's going to be too long before this pillar here is worn away. And when it is, everything above is going to come crashing down.
This rock fall may protect the cliff for a little while, but in time the sea will break it up and carry it away. There's enough energy in waves like this to carry off hundreds of tons of material on every tide, but the coast is not totally defenseless.
One of the best things to absorb the energy of the waves is a nice, wide, sandy beach. Now, if you look closely at a wave when it breaks, you'll see that it washes sand up the beach, and when it retreats, it washes it down again. And most of the energy in the waves is used up just moving sand around.
If the waves hit the beach square on, then the sand is just moved up and down the beach.
But if the waves hit the beach at an angle, like they are here, then they wash the sand up the beach in this direction and down again over there. And that's what we call longshore drift. In other words, the sand and gravel around our coastline is constantly shifting, like a moving carpet.
Not all of our coastline is natural. About a quarter of our coast is now protected by sea walls, many of them built after the 1953 storm that did so much damage to towns on the east coast. But perhaps an even better way to defend the coastline are these, wooden groins.
They look like walls built out to sea and are designed to stop sand drifting along the shoreline. By trapping the sand, you retain a nice, wide, sandy beach which protects your particular stretch of coastline. And very effective they are too.
But they can cause problems. Any wall built out to sea can interfere with the natural movement of sand along the coast, the longshore drift. This harbour mouth was built in the 19th century, and it's caused immense problems to the town of West Bay in Dorset. It's trapped the sand on one side of it, with the result that the sand on the far side has moved on down the coast, but none can come along to replace it. These houses now have to be protected by hard sea walls, where before none were needed. The lesson from West Bay is that interfering with the coastline in one place can really cause problems for places further along. But even if we've learned that lesson well, putting it into practice can still be difficult. This is the village of Mappleton, on the Holderness coast where this programme began. So much land is being lost from this stretch of the coastline that barriers like this have to be moved 2 or 3 times a year. Clifftop Farm will soon be just another memory to its last inhabitants. When it was built, it was several kilometres inland. Within living memory, it's lost this much land to the sea.
The problem here is that the cliffs are made of a very soft rock called till. And it's really just clay with a few stones in it. But there's another problem here. At high tide, there's really very little in the way of a beach to protect the cliffs against attack by the waves.
If nature had been allowed to take its course, parts of Mappleton, just like this old house, would now be under demolition. The village would be preparing to join the roll of the 29 lost villages that have been swept into the sea since Roman times, from Wilsthorpe in the north to the strangely named Ravensor Odd in the south. 200 years ago, the village was 4 kilometres from the sea. 6 of Mappleton's houses have already gone in the last 15 years.
My house was well over a quarter of a mile away from the sea. I can remember fields being around there. And there was the parade ground that when it was the army camp. And there was the gardens. They've all gone now.
But Mappleton has had a last-minute reprieve. And this is the reason. The main road from Hornsea to Withensea runs through the village. The local council worked out that building sea defences would be far cheaper than the cost of moving the road back. If a wall could be built out to sea, it would encourage the sand to build up in front of the village, and that would absorb the energy of the waves and protect the soft cliffs from erosion.
So the local council decided to build these sea defences to trap the sand. Now, some people argued that building these sea defences might cause problems further down the coast, and it looks as if they might well be proved right. On this side, we've got a nice wide sandy beach, and that's protecting the cliff. But on this side, it's a very different story. We've got a very narrow beach, and the waves are coming right up to the cliff and eroding them away.
The farmers just south of Mappleton have been the first to complain. A crop of winter wheat, planted in the autumn, has disappeared into the sea by the following spring. Sue Earle's family moved to Great Cowden Farm in 1957. At that time there was a whole field between them and the sea, enough, they thought, to last their lifetime with a little to spare. 35 years later, and the sea is at their door. Sue has seen the erosion of her land increase dramatically, and she's convinced that the new defences at Mappleton are to blame.
We would have approximately 50 metres of good big field out there where we grew crops. But now, at that rate of erosion would be approximately a metre a year at that time. But since Mappleton had been built in '91, we've lost 20 metres in many places.
20 metres? So you lost that much in a year?
In 1 year, yes. Which is an alarming rate. So if we continue at this rate, many of our buildings will have gone in the next 2 years. Well, as soon as we saw the big cracks appearing, we started taking measurements. But then if you looked at the beach, there was no sand, and sand is your basic protection. The sand gathered up at Mappleton due to the defence there, so our sand depleted. So the sea was hitting the bottom of the cliff every day, and the erosion increased.
And was it only in storms or just every day?
Every day. Even the neap tide would get it right to the top. It would hit the cliff every day. It was just hammering it. So the bottom, it would just cave out and we'd get a crack and it would just drop.
So is this rock barrier at Mappleton responsible for the havoc that the sea is wreaking further down the coast? We decided to put Sue Earle's theory to the test at the Earth Science Laboratory at London University. There, in a wave tank, we made a model of that bit of the coastline. There's Mappleton, perched on the edge of the cliff, and there's Sue Earle's farm, a little way to the south. We invited students from Fortismere School to carry out the experiment.
We'll make a start now and try and build a sea defence beneath the cliff face to recreate the sea defences that have actually been built at the real place. They'll wash even more than 2 centimetres up the cliff face. It needs to just break the surface of the water.
When the rock barrier was in place, it was time to start the wave machine.
How's it looking? Heidi, what's happening at the northern end there?
It's all going.
Bottom of the cliff.
It's eroding.
Eroding, yeah, well done.
But here isn't.
Quite strongly. It's obviously making the cliff face very unstable.
Come on.
On either side of the barrier, the land is disappearing quite fast. The village itself is protected, but the farm to the south is soon in danger.
It's jammy. What are you
Drop the wave machine now, please. What a storm. So, how effective was the sea defence that you built, do you think?
It's really good.
It protected the village, but the rest of it
Right, good point. Right, so protected the village so far.
waves were broken, so it didn't get eroded as fast.
What about the effects? What about the effects down here, do you think? Yeah, catastrophic, do you think? Yeah. Do you think it's affected the way in which sediment has moved along the coast?
Yes, it stopped the sand from travelling along the coast.
Stopped it from moving along the coast?
Yeah.
Yeah, so it stopped the
Longshore drift.
Yeah, longshore drift.
So it does seem that Sue Earle's farm, like this gun emplacement, may fall victim to the sea sooner rather than later.
But erosion is only part of the story. The enormous quantities of mud, sand and gravel that are swept away by the sea are not completely lost. In other parts of Britain, the coast is growing outwards and land is being added from the sea. Now that process is called deposition. So all around the coastline there's a complicated process of give and take, with material eroded from one place being added in another.
This mud is gradually getting deeper as more material arrives with each tide. One day the bare skeleton of this boat will disappear underneath it, perhaps forever. The strange curving shape of Spurn Head is made largely from material eroded from the Holderness coast further north. But John Pethick of Hull University argues that if we stop the Holderness coast from eroding, it could have disastrous consequences for other coastlines, and not just in Britain. What makes it so special?
It's probably got the biggest erosion rate in the world, about 2 meters a year, which puts it on the map, or in fact taking it off the map very rapidly.
So where does all this sediment go?
We know definitely it goes into the wash. We also think, we haven't got absolute proof, but there's a fair amount of circumstantial evidence that it goes to Holland, and it feeds the Bodensee, the German coast, and the Danish coast.
So should this coast be protected at all?
The land here is not worth a great deal. It's agricultural land. Where the mud is going is to protect the mudflats in front of some very important towns such as Amsterdam, London, King's Lynn, and an enormous amount of money is at stake. What those mudflats are doing are trying to build up in the face of sea level rise, which was threatened because of global warming. And if that mudflat doesn't build up in front of Amsterdam, London, King's Lynn, then we're liable to have flooding. And what is most important to us is what we ought to be asking. Should we be protecting agricultural land here by stopping the erosion, or allowing that erosion to take place and protect some of the biggest cities in Northern Europe?
It's hard to think of this energy as being anything other than destructive, especially if it's your own land that's being taken. But the land doesn't simply vanish. What's eroded from one place is deposited in another.
And this is where some of the mud from the Holderness coast gets deposited, on the salt marshes around the North Norfolk coast. And this mud, which may once have been part of a farm around Humberside, is now playing an absolutely vital role in protecting the coast further south.
It was around here that some of the worst flooding happened in 1953, when that storm hit the east coast. Salt marshes, like beaches, are an excellent first line of defence against the sea. They soften the force of the waves before they reach the villages inland. But some of the land that was once salt marsh has been reclaimed, protected and cultivated.
Some experts are now having to think the unthinkable, that there are some parts of the British Isles that we just cannot go on defending against the power of the sea. And this is exactly the sort of land which is most at risk. Farmland well below the high tide level that's protected against the sea by walls like this. The problem is that sea walls cost a lot of money to build and maintain, and it's getting more and more difficult to justify spending millions on sea defences when the value of the agricultural land they're protecting is falling.
Our coastline is also threatened by two much greater problems. By the middle of the next century, sea level may rise by between 30 and 50 centimetres. That's enough to cause major problems for many of the world's cities and for much of our coastline. Severe storms that we used to expect once every 150 years are becoming more frequent. They may now happen as often as once every 35 years. Wherever possible, sea defences will be maintained and strengthened. But many of the walls that were built 40 years ago are already in need of repair, and those repairs don't come cheap.
In the next 50 years, we're going to have to make some very difficult decisions about the British coastline. In the end, the sea will always get its own way, and there's very little we can do other than slow that process down. Perhaps the most valuable lesson we've learned since 1953 is that it's better to work with nature rather than against it. And that offers us our best chance against the next big storm.
Now the shipping forecast issued by the Met Office on Saturday, the 5th of January 1991. There are warnings of gales in 4 areas. Comedy falls time.